infrastructures. Take it away.
Good morning, everybody. So yes, as Brad says, I'm here to talk a little bit about building out dynamic media infrastructures specifically for Tier 1 live production. I was actually here yesterday listening to what Andy had to say and Thomas and Raul from Intel, and I think there's an interesting theme there. And I think as I step through some of the slides here and talk about some of the case studies, you're going to see there's probably a little bit of extra work that we as a group need to do in order to progress this. So what do I mean by Tier 1 sports? So just to kind of set the tone, this is the largest sporting events in the world. It's not just MCR, it's also bringing trucks to venues, it's bringing fly packs to venues, and it's also distributing that content on multiple other platforms. So whether that's TV, over the top, or even to radio distribution. But if I break it down even further into the global events, these are truly the largest sporting events. So things like the Olympics, the World Cup, the Euros, these are massive infrastructures that are built purposely for those events. And they are really used with cutting-edge technology. So as you've seen over the last, I would say, 5-10 years, the adoption of IP has been pretty much well accepted by a lot of these global events. And in terms of scale, you're talking of hundreds of cameras, lots of production switches, lots of channels of UDX providing all the world feeds, all the transmission feeds, and also a lot of monitoring, so large multi-viewing stacks. And in recent years, we've seen a lot of sort of purpose-built infrastructures that get built specifically for that event, like, for example, here, where we see the containerization of the facility, and then within there, they're building up things like audio suites and galleries to complement the production. So these are large productions with a lot of scale, and they are generally built specifically for that type of event. So as you heard actually through a lot of the presentations, when we start talking about dynamic media infrastructure, is we have to look at the way that content is created and the way it's distributed. And so if you kind of break that down into 3 layers, at the edge where signals tend to come into the network, there will always be a need for encapsulation, decapsulation of signal types to come inside the network. There will always be human interfaces around where people want to interact with the content. And then there is processing that can really sit wherever the customer or the production wants to have that. So whether that's processing at the edge to eliminate things like the audio round tripping, or whether it's putting in data centers or even moving it to the cloud. And so there are a lot of sort of factors that come into play here, things like latency, compression, bandwidth that's available, as we just heard in the last presentation, also resilience. And so what we see in terms of dynamic infrastructure is customers are wanting to be able to be more flexible with their infrastructure and put the processing exactly where they need it, and then tear it down afterwards and then move it to somewhere else without actually having to go physically and remove it. So what does that look like? And I think this was touched on yesterday, so more modern infrastructure, so containerization or microservices. And there are kind of 2 areas of that space. There's what I call the orchestration layer or the control layer, where you want to have things like discovery, registration, inventory management. It was also touched on SDN control of the network, and things like management of things like licenses, applications, metrics, monitoring, all the things that you need, and even things like legacy support, so protocol translators, whether that be from existing protocols into the more modern world, or making this dynamic media infrastructure MMOS aware. So effectively doing a gateway to allow you to, as you instantiate applications, you're able to discover them, and once they go away, they'll be teared down from the registry. The lower layers, the infrastructure, and I think Raul did a great job of talking about this yesterday, is that we actually don't care, it's compute. And it's compute with network infrastructure, whether that's 100, 200, 400, or even in the future 800, it's connected processing compute. And what you want to do is to be able to instantiate any application at any point on any node. And so depending on the configuration, depending on the capacity that's required, be able to deploy exactly where that node is based. So what are apps? Apps are basically functions that provide video and audio processing. They can run CPU. or as you've heard, I think, over the last couple of days, it can run CPU and GPU. They are native and they provide a specific functionality, for example, like UDX or multi-viewing, or even break them down even further, and again, I'll touch on that. They are typically deployed dynamically or orchestrated, and the architecture is typically highly desirable based on containerization. And of course, in this model, it opens a bit more flexibility to customers to think about whether they want to perpetually own those functions or whether they want to license them more in a more flexible OpEx type model. So why containers? First of all, they're easy to boot. So when you want to instantiate an app and you want to then shut it down, it's seconds. They're really small because they're abstracted from the underlying OS. They're highly efficient, and I'll show you a few slides about that. And also you can generate isolation. So if you want to have multiple applications running, you can create a number of isolations in there. And one of the things that is becoming more of a theme with customers is security, so being able to secure the application independent of the underlying OS. And from a vendor perspective, it allows us to take different combinations of those containers to generate new applications, which means that it's a faster time to market and it brings more value to our customers. And probably the last one was one that's probably a little bit underestimated, which is when we want to do version up or bug fixing, I don't need to compile the whole thing. I can just address the container that needs the fix and just instantiate the fix to that container. And it's very easy to roll it backwards and also upgrade. So what does that look like? Obviously, you end up with a container library. In that library, you end up with things like 2110 senders and receivers. That can be uncompressed, JPEG XS. You can end up with NDI, senders and receivers, support high bandwidth NDI, HX2, HX3, and the three-letter acronym that I won't mention, but you can also have that as a sender and receiver, and again, with your choice of H.264, HEVC inside of it as well. And then there are microservices for the processing. So in an app, you may share some of these microservices across a number of the apps. So deinterlacing, scaling, color correction, HDR processing, test pattern generation, and graphics insertion, so HTML graphics insertion. And of course, that library can build over time, which as you bring new applications and different combinations with them. So what does it look like in an application? Typically, you have an input stage. So in that, you have your choice of inputs. So whether you're coming in one format, you have your processing block, and in that processing block, you can instantiate which processing you need inside of that. So if it's different options or different processing blocks. And then you can also have an output stage. So go to another format, or you can actually do a zero copy from the memory, and you can effectively make as many output stages as you like. So once you've taken a number of these containers and you've instantiated an app, for example here like a multi-viewer, you might have a number of inputs, a number of rescalers, some a compositor for the multi-viewer head, and then you want to send it back in the network. This in itself is a virtual app that's made up of a number of containers. And then you can instantiate that through the orchestration layer. So you can say, I want to go run this application. I go run it. It'll pull down from the registry all of the containers that are required. It'll run them in place. And then once it's finished, it'll remove them in place and free up the compute again. And so in that model, it's highly scalable. So you can go from different apps on server 1, 2, and if you want to scale that out into public cloud. So as the customer has more need or more requirements, you can just scale it very, very easily. The other benefit is, because you've detached the software away from the hardware, is you can have, for example, in this case, all the multi-viewers running on one box, but you can easily, very quickly, within seconds, instantiate UDXs, stream transcoders, graphics inserters, and you can even expand that out to an N+1 model. So rather than having pairs for redundancy of specific boxes to do specific tasks, you can just say, I need to run these applications, and I can say, okay, I have a pool of compute, and I just want to say if an app stops on server 1, because server 1, for whatever reason, is no longer available for me, it can be reinstantiated, and it will automatically go to the next available one, or to the one that's dedicated as your spare. And Thomas made a good point of that, and I think this is really an important factor, that by design, this type of infrastructure needs metrics and monitoring by design. Has to be baked in from the beginning. Otherwise, you can run into a lot of instances. Yes, there's issues around wanting to track the commercial costs of this infrastructure, but also because you're dynamically moving things around in your infrastructure to get the benefit of it, you also want to know what's happening with that infrastructure. So the nice thing is, a lot of this technology, cloud-native technology, has, by the nature of it, this type of functionality built into it. So just to give you an example of the apps, you can see the number of containers running on a server, you can see the CPU load, the pinning, you can see memory utilization, you can see network bandwidth utilization. And so very easy as you bring up apps, you can see what it's costing you from a compute. And also you have historical data, so you can go back over time and look at where it was used and which apps, which cost, and so on. So I want to just talk a little bit about case studies, because I think you heard yesterday a lot of interesting information about how this technology could actually be realized, but I actually want to share with you a couple of case studies where this technology has already been used in these types of environments. So Lavo has a long-standing relationship with HBS, or Host Broadcasting Services. For those who don't know who HBS is, they were founded in 1999. They're based in Switzerland, and they have been the host broadcaster for a number of sporting events for many, many years. And so the first one was the 2002 FIFA World Cup in Korea and Japan. And they have really provided everything from project management to delivering these large-scale sporting and global events. And for those who have an involvement in any of those sporting events will know that they have, for many, many years, been pushing the boundaries of technology. So HD, IP, UHD, immersive audio, HDR, and more recently into dynamic media. But from a Lavo perspective, we started the relationship and the partnership with HBS many, many years ago as they transitioned into IP over, audio over IP. So the first case study was there was a major sporting event during summer of 2023. That was a very large 2110 converged network, cameras, switches, multi-viewers, audio, lots of I/O. And for that, this dynamic media infrastructure was used to provide all of the transmission world feeds to all the broadcasters from the host broadcaster, and providing not only HDR to SDR conversion with custom LUTs, but also doing 1080p to 1080i conversion for a number of the broadcasters. And that technology stack is COT server platform, is a Dell platform, 64 cores, 128 threads, dual 100 gig network connectivity for Dash 7, and running a Linux and Ubuntu distribution with low latency kernel. So something that you can go order today from Dell and deploy relatively easy. So what does that look like? Those apps had typically a feed coming in 2110, going into the UDX, doing an output in HDR to SDR conversion, so 1080p in, 1080p out, so HDR to SDR, and at the same time doing a 1080p to 1080i SDR down as well at the same time, simultaneously from the same application. And so they were able to instantiate the apps on the servers and move the apps around depending on where they were required. And in that case, they had an N+1 server sat there in the event that they needed to move from one server to the next. What does that look like if you would go into the processing node and you would start looking at what's going on? You would see that once we instantiate the application, it goes and pulls a bunch of microservices down from the registry. There are some services that run natively on the box, so things like Warden, Bundle, and Tick. They are doing things like the orchestration, the discovery of the node, timing, and all the metric scraping. And then you have the input stage. In this case, you see it as 2110. So containers for the inputs and outputs for both video and audio. And then some of the processing, so the deinterlacing and also the AV store. And so as you launch the apps, you instantiate them on the node. This is what you would typically see. Once you shut the app, then it will come back and you'll only see the last 3 containers that are running. You also see in this case, the address of where it came from, and you also see the version control. So container image versioning. So if I want to do a fix, I can go quite quickly. If I want to go back, I can go backwards quite quickly. I don't have this full task of upgrading the whole software, checking it all, and then rolling it back. It's really a simple click process. In the case of the UDX that we used at this spawning event, there were 2 outputs. So obviously now you can see that there are additional microservices instantiated to provide the second output, so the second video, and again, the second group of audios. So, so this was, like I said, providing all the transmission feeds, HDR, SDR, 1080p, 1080i. But we also did a second global event with HBS last year as well. And this was towards the end of the year in France. And in that case, again, it was a large 2110 infrastructure. All of the venues around France were connected on 100 gig infrastructure. At those venues, all the in-cap, decap was placed. So getting all of the signals backhauled in 2110. With -7 through diverse paths, again over telco network. And in this case, we had not only the edge encapsulation, but we also had the multiviewers back at the IBC. And again, using exactly the same servers, customers able to just instantiate different apps on the same infrastructure and basically bring up what they need for doing that processing. So again, not too dissimilar. What does that sort of application look like? In that case, it's the reverse. You've got lots more on the input stage because you've got all of your sources coming into your multiviewer. You've got your processing, which is doing the graphical overlays, things like labels, tallies, layout, and so on. And then you have also things like the scalers. And then on the output stage, you're able to deliver the head in multiple streams. So in that case, for example, I can take the same head and send it one way in 2110, but I can also take it another way and deliver it in another format. So again, remember that when you instantiate the applications, you can choose which services that you want to instantiate with that application. So again, if you look at a similar approach there, the core services are there as well. Similar thing with the inputs. You have a bunch of containers for the inputs for video and the audio. You have some of the processing. So in this case, you have the graphical overlays, the multi-view graphic overlays, and then you have the sender, so the retransmission of the multi-viewer head into the network. Again, you see in this case the video and the audio. But of course, it's really easy if the customer says, I want to have an NDI output of the same multi-viewer. I don't instantiate a whole new application. I don't put any boxes behind it or any more gateway conversion. I just tap another microservice in at the back end, and I read the same out of the same frame store. So in this case, it allows really the applications to serve the customer infrastructure very dynamically. So, and I guess one of the things that we learned in this process is you can also unlock different redundancy models. So yes, you can have active-active for apps and just flip and flop between the apps and the network. But because the applications start very quickly, you may choose that you don't want to consume double the license or double the compute to do that. You just simply want to start it and have it reinstantiate on a second processing node, and that happens in a matter of seconds. So like I said, in this case, this project had multiple venues scattered across France. At each of the venue, there was high density SDI to IP conversion that was connected directly into 100 gig infrastructure from the telco. At the venue, all the cameras, the truck that was there was all connected up, and it's all backhauled into the IBC. And back at the base, they have the multi-viewing, and they're able to round robin the venues to see what's coming back from the venues and what's being sent out to transmission. And from a kind of compute perspective, it's just a rack, like I said, of Dell servers that can be simply repurposed for different applications depending on the customer need. So what did we take away from this? There's a lot of talk in the last couple of days about dynamic media infrastructure. Yes, there is still work to be done there, but the reality has been realized today. Everything I talked about here is in shipping product today. It is proven at scale, so you can go and launch a lot of applications linearly on compute and then scale it outwards with more compute nodes. It does serve the highest tier of sports, so the big sporting events. Cloud-native technologies actually play quite nicely on-premise, so we heard about a lot going to the cloud. There's some real benefits of using the agility and the flexibility that those technologies bring also on-premise, and we see more and more customers wanting to build that infrastructure on-site and then burst to the cloud when they want to, or find a good blend of both. Latency and processing concerns is always something that's raised around using software and compute. In our case, the customer was also, for these two projects, wanted to spend a lot of time. We spent a lot of time with them up front to go through latency, go through picture quality tests. And the technology is moving very, very quickly. So even though the technology we deployed last year, we built up in March, April last year, was deployed in July. From what was deployed then, 64 cores, now we're deploying the 96-core version of that hardware infrastructure, and it's cost neutral. Didn't cost us a single penny more. And it didn't cost us any R&D money in order to increase capacity. That it's just the organic curve of being able to ride that wave. And network infrastructure is getting more and more readily available. So the technology that was using those servers is 100, 200 gig, but I'm also able today to go put a 400 gig NIC into that infrastructure as well. So where do I see that there are some areas where we could try harder? There is, of course, a skills gap that needs to be addressed. So this technology does use things like having awareness of DevOps, so instantiating the processing nodes is using things like Ansible. You heard from Thomas about CI/CD workflows. That's also very beneficial here. There's a big pool of people that know that outside our industry, and yes, some of them come in. And that's something that we've also had to embrace as a vendor. But I think you shouldn't underestimate the impact on our customers. So some of our customers are making the investment, but of course they're not going to remove all their broadcast engineers at the same time. So there is a bit of skills gap and a bit of education and training that needs to take place in order to bring them up to speed to really leverage this type of technology. What do we see as next? And so what we see next is more global events. We already have 2 major global events this year in France and Germany, where we will deploy again this at scale. So over 250 plus channels of UDX, delivering UHD, 1080p, 1080i, HDR, SDR for all of the transmission outputs. So I think the conclusion I take is that there is, the technology is there, it's available. As I think you heard from Andy, there's some areas where I think the collaboration between vendors could be good, things like RDMA. That brings the discussion around how you hand off video and audio data between vendors. That's maybe an area which needs a discussion. But again, I think from a technology perspective, riding this curve for Lavo, we cannot invest anywhere near what the hyperscalers can invest. So the Intels, the NVIDIAs, and the AMDs. So for us, we already see, even within the last year, that riding that curve brings massive benefits. So at that point, I'll wrap it up and open up for any questions. Thank you.
Thank you very much.